In this video, we will simulate the VisBreaker and its associated fractionator. The bottom product from the vacuum distillation will go into VisBreaker to recover more of the lighter components. In the reactor section, there is a unit operation named VisBreaker. First of all, it will ask you either your VisBreaker has soaker drum or not. If your VisBreaker has soaker drum, it will ask for the volume of the drum, otherwise it will not ask anything. So first we have to attach the feed stream, which is the vacuum bottom, and out is whisk effluent. In the furnace and drum specification, you need to define the parameter for the heating furnace. And you need to define the volume of the soaker drum. There is nothing else required to solve the VisBreaker. It's a simple unit operation. However, the effluent need to be treated in a fractionator. So we will install a column. So in this column, the feed is entering at the bottom. The column has 30 number of stages. Column top has a condenser, which has the type of food reflux. Top is the vapors, and the side draw is whisk naphtha, while the other is LGO, light gas oil, and the third side stream is HGO. At bottom is tar. The naphtha leaves from the stage 3rd, LGO from 18, and HGO leaves from 24th stage. The bottom pressure is 1.9 and top is 1.4. We don't have any side ops in this case, so we go to the monitor, and first of all I will define the rate of draw. So it has been converged, same as the other two towers. Now we will add the set points depending upon the temperatures. LGO draw from stage 18, so the temperature would be Before going to the specification, I will add the efficiencies of the trace. Now we will meet the specifications. The tower has been solved. It had produced 4 different streams. Now the third stream has the very high viscosity, while the light component from the tar has been recovered. In the next video, we will simulate the catalytic reformer to treat the naphtha from the atmospheric fractionator.